Good morning, class. We are starting our right triangle unit. So before we start our right triangle unit, we need to talk about simplifying radicals. All right. So we're going to do a review of some simplifying radicals that you should know, and then some of things that we may not have covered yet. So some basic things that we should know. Powers of 2. To the second power. So 1 to the second power, we know that is the same thing as, we don't need that. That is the same thing as 1 times 1, which equals 1. We know 2 squared is 2 times 2, which equals 4. All right. So 3 squared is 3 times 3, which is 9. Not And 4 squared is 4 times 4, which equals 16. And we know 5 squared is 5 times 5, which equals 25. All right. So 6 squared is going to be 36. Pardon, my handwriting is awful today. Is 36. 7 squared is going to be 49. 8 squared is going to be 64. 9 squared is 81. 10 squared, 100. 11 squared, 121. 12 squared, 144. 13 squared, 169. 14 squared, 196. And 15 squared, 225. All right. So those we should know. Okay. You need to know all your perfect squares all the way up to 15. Okay. So when we want to do the radical, when we want to simplify a radical, we are undoing a perfect square. So 49 square, the square root of 49 is 7. But why? Because 49 we know is the same thing as 7 squared. 49 is the same thing as 7 squared. So this is actually the same thing as the square root of 7 squared. And so what happens when we do that, the square root and the square cancel each other out and leave us with the value. Okay, so that is what's taking place. The square and the square root are canceling each other out and leaving us with the value. So 121, again, same thing happens. We have this is the same thing as the square root of 11 squared. The square and the square root are canceling each other out because they are opposites of each other, just like multiplication and division, addition and subtraction, which leaves us with 11. Okay, so this makes sense. If these are perfect squares, it makes it very easy for us to find the answer. So the square root of 225 would give us 15. The square root of 169 would give us 13. So the ones that are perfect squares, we don't have to show a lot of work, and it makes it very easy for us to find the answer. But what happens when it's not a perfect square? When it's not a perfect square, then we have to do things a little differently, because we still have to simplify the radical, and we're not going to be able to use our calculator, and we have to leave it in radical form. So I want you to remember what you did back in junior high. Remember when you did the trees? You did the trees, and you said, oh, what are the different ways I can multiply to get to 50? But when you do that, I want you to look for perfect squares. Well, I know 50 is the same thing as 2 times 25. And this is the same thing as 5 times 5. So that means this is going to be the same thing as, where's my colors? There we go. This is going to be the same thing as the square root of 2 times 5 squared. So, and this is where I would tell my students a story in class. When you have to, your parents ask you to wash the dishes or you do something and you do it, then you would get to go outside and play. And if you didn't do what your parents asked, you would have to stay in the house. Well, my square root symbol is like the house. And only the good square kids get to leave the house. So anything that has a good, perfect square gets to leave the house. And anything that doesn't have a square on it has to stay in the house. So if we look at this problem, the 5 has a square on it. It would get to leave the house. The 2 does not have a square on it, so it'd have to stay in the house. So that means this would be the same thing as 5 square root of 2. Since the 5 had a square, is a perfect square, that means it's going to cancel with the radical so that the 5 can come out. The 2 did not have a perfect square, so it has to stay inside the house. Okay? Let's try another one. Number 20. Again, tree. So that's the same thing as 4 times 5. I know this is the same thing as 2 times 2. So I've done my prime factors and I did my tree. I'm going to go ahead and rewrite the radical. So this is the same thing as the square root of 2 squared times 5. Now again, only the good square kids get to come outside. So now I can rewrite this. So the 2 has a square on it, so the 2 gets to come out. And now the 5 has to stay inside. So I get 2 square root of 5. Next, 18. We'll do the same thing again. So, tree. So I know this is the same thing as 9 times 2, which is the same thing as 3 times 3. So that tells me that this is the same thing as the square root of 2 times 3 squared. The 3 is a perfect square, so it gets to come out of the house. And the 2 is not a perfect square, so it has to stay in the house. So this becomes 3 square root of 2. Okay. 72. Tree. So I know this is the same thing as 9 times 8. I know this is the same thing as 3 times 3. This is the same thing as 2 times 4. And this is 2 times 2. And so I'm going to write this, but ladies and gentlemen, when I write this, I want to write it so that it's in pairs of 2. So I have 2 times 2 squared, right? Because I have a 2 here, a 2 here, and a 2 here. And I want to pair them in 2. If I can put squared, that's what I want. 3 squared. Okay? So I have a 2, which is here, and then I have 2 times 2, which is another 2 squared. Now the ones with the square get to come out. So now that gives me, so that gives me 2 times 3 on the outside, and the square root of 2 on the inside. And I multiply the numbers on the outside. 2 times 3 is 6. Square root of 2. Alright. ladies and gentlemen. So we can do the exact same thing if we have variables as well. We can do the exact same thing if we have variables. So if they're perfect squares, I can just go ahead and go straight to the answer. 64 I know is a perfect square. X squared is a perfect square. So the square root of 64 is 8. Square root of x squared would be x. I know I skipped ahead, so let me just make sure I wrote that right. So this is the same thing as 8 squared x squared, and then they get to come out. Okay? Here, I know I get excited. So this is the same thing as the square root of 9 squared m squared n squared n squared n squared, right? Because I'm breaking everything into perfect squares. So that gives me the 9, everything with a perfect square gets to come out of the house. So the 9 comes out, the m comes out, and I have 1, 2, 3 n's come out. Okay? So here we go again. I know 196, well, 196 is a perfect square, right? Because 196, I know that's going to be the same thing as 14 squared. And then x cubed, well, that's an x times an x squared. And y to the 5th, well, that's a y. Y squared, y squared. So the ones with the perfect squares get to come out. And if you don't have a perfect square, that means you have to stay on the inside. So this one comes out, this one comes out, this one comes out, this one comes out, and that means this x has to stay inside, and it means that this y has to stay inside. All right, so the 14 comes out, so that gives me 14. X comes out, 2 y's come out, so y squared, and on the inside, x times y. We're doing the same process. Now, if I do not have perfect squares, that means, what does that mean? I have to do my tree. Tree. So 6 times 10, 2 times 3, 2 times 5. So I can rewrite this as the square root of 2 squared times 3 times 5 times x squared times x squared. And the good square kids get to come out. So the 2 gets to come out. The x gets to come out. And then this x gets to come out. So I get x squared coming out. And what's left on the inside? The 3 and the 5. 3 times 5 is 15. Okay. The next one. Again, 21 is not a perfect square. So I'm going to tree. So that's 3 times 7. 3 times 7. Well, there are no perfect squares there. So it looks like it's going to stay in. So I can still rewrite this radical. So 3 and 7, and there are no perfect squares, so I'm going to leave it as a 21. And then I have m squared, m squared, m squared, m squared. I'm running out of room, so I have n squared, and another n squared. So all that's underneath the radical. Since I ran out of room. So that's going to give me, what comes out? The 2 m's come out, the 3 m's come out, and this is actually supposed to be in